Hi, I'm Rob. I recently made a claim on Twitter. I said all members of the Rome cult should really be learning how to use queries and learn how to use them well, right? And the reason that I said that is because queries are Rome's language for expressing questions and answering questions for you. Like if you're a fan of how to take smart notes, which I know many of you are. One of the core principles in it that it describes is that you should try to set up your notes so that way you can have a conversation with them. And one of the core components of a conversation is being able to ask questions. Like I want to be able to ask my Rome database a question like, have I thought anything related to this before? Or alternatively, are there relations that I haven't conceptualized yet? And are they here in Rome, in my Rome database? And the thing about it is just that, like Rome is just such a beautiful mess. Like I put so much writing into Rome that I need some way to wrangle the chaos, and queries are the way to do it. Now, after I made that tweet, a bunch of people got back to me asking, like, okay, how do I make a good query? And I realized that I haven't really seen any good thinking on this before. Like I've seen some very rudimentary examples, but I haven't really seen anything that just explains the core logic for how queries work and like the syntax of it. So that's what I'm going to try to do in this video. So, with queries, you have a few basic tools. So I have you have three different logical operators. You have and, you have or, and you have not. And with and, what you're essentially saying is that here, if I have a query and I have and page 1, page 2 in there, then that means that any block that I have written in my database that mentions both of those is going to show up in my results. Or I'm saying either page 1 or page 2 can show up in my query. And not is saying anything but page 1 can show up in my query. And then where it gets really powerful is that you can actually embed these operations within each other. And in order to do that, I want you to think a little bit about math and parentheses in math, right? So here, what we're saying is 3 times whatever this is, because this is wrapped in parentheses, and we're also saying 15 divided by, what's in parentheses here, which is 2 plus 3. So 2 plus 3 equals 5. 15 divided by 5 is 3. And then 3 times 3 equals 9. Right? So that's essentially how these curly brackets work in conjunction with these logical operators. So I might be able to say and page 1, page 2, not page 3. And what you'll notice is that not page 3, that's embedded within and within that and command. So what you end up getting is this would show me any of the blocks that I have that mention page 1 and page 2 and not page 3. All 3 of those conditions have to be true in order for it to show up in my query. So now I'm going to zoom in a little bit on like what they let you do. So it lets you ask your database, what have I written about this already before, and really just pull in insights from many areas. It lets you like zoom in on things in a way that linked references on their own don't necessarily do. So an example of this is like, let's say I want to prepare for a talk about gamification. Like I might think, okay, uh, really, I just want to see anything related to difficulty matching or failure states or user goals. Those are 3 pages that I have that are related to gamification. Uh, and those thoughts don't need to all be together. It's an or operator. So I'll write a query for that. You know, um, I have, first I write out query, or here, I'm actually just going to write this out live for you, just to show. So first I do double curly brackets and query, and I put that within a page name, and that is how you start out this query. Then I put like the colon there right after it, and then one set of curly brackets. This is just like the parentheses that I showed you earlier in the mathematical equation. So I'm going to say or any of these pages, difficulty matching, failure states. That page was actually just singular. I usually do singular. And then user goal. Okay, and then that query is going to pull up all of those thoughts. I just asked my database a question and it answered it by saying, here's what you've written related to this. Anytime you've mentioned any of those concepts, it shows up here. Okay. Next example is, let's say this is actually a really common problem that a lot of users have, is that you can use multiple words to describe the same thing, right? So perceptual control theory, that's the same as PCT. They both mean the exact same thing, but I've just written it both ways, and I don't want to have to remember which way that I've written it. And on top of that, when I'm on the page for PCT, I don't want to like suddenly lose everything that I've tagged perceptual control theory, because they mean the exact same thing. So I could actually embed a query that pulls up all of my notes related to perceptual control theory or PCT, and I could put that query onto the page for either of them. And that would allow me to just like see all of these, see all of the notes. I wouldn't need to tag everything with PCT or that. So here's the example of this. I've got a query and I say, or PCT, perceptual control theory, because those two words, they're the exact same thing. So we can say or there. And then I also say and, not query. I'm just doing that to exclude some stuff. Actually, I think I wrote this wrong, and I'm going to try correcting this real quick live for you. So I'm going to write a query for this. Query and or PCT. And then I'm moving beyond this curly bracket because the or and perceptual control theory are going to be linked, but I also want it to exclude all other queries that I've written before. So I'm going to write not query, and this is all embedded within this and command. So it's saying this needs to be true, and so does this. Yeah, and so now we have a good, clean query. And the reason that I do it that way is just because if I already mentioned this earlier in the video, whatever, is just because if I don't exclude query, then it'll show all other queries that I've made, and that just gets really annoying. It's just not clean. So now moving on to the next page. This is this one. I'm doing the exact same query as I had before, and because I'm trying to find anything related to perceptual control theory or PCT. Those theories both mean the exact same thing, but I want to see like what Warren Mansell has written about it. I don't want to see like anything else. All I want to see are notes that Warren Mansell has written. He's a professor that is very relevant for that theory, and I want to see anything he has written about perceptual control theory or PCT. And so the way that I do that is I've got this and operator, and I have or PCT and perceptual control theory embedded within the and then I also have Warren Mansell embedded within the and. So that means both Warren Mansell and this need to be true. If both of those are true, then it'll show up in the query. Yeah, so now I can see everything that Warren Mansell has written about perceptual control theory. Now, some of you may be asking, like, why wouldn't you just do linked references for a lot of this? And I will say, like, a lot of things that you can do with queries, you can also do with linked references. Linked references definitely don't do everything, right? Sometimes you can only express it as a query, but for the situations where you do have linked references, like let's say I pull up the linked references for perceptual control theory, which I should have just open and ready out here. I'm filtering in a certain way, so I'm seeing every time I've got PCT and Warren Mansell. But if I change that, then that's lost to history. I'll forget that, and I'll need to do that again next time. Sometimes I want to have like a saved view of how I'm filtering my notes. And that's where like queries can be really effective. So what I just expressed to you, I could also do as a query here, query and PCT Warren Mansell, and I'm also just going to exclude any query. Yeah, and so that's the exact same thing as what I have above, but because it's expressed through a query, it has a level of permanence to it. And then the last example I'm going to show you, this is combining some of the principles that I taught you earlier. I really think that it's helpful to think about Rome as a puzzle game. Like every time you learn about a rule, start to like figure out like what the other rules that it can connect to are, right? Like so when you're playing video games that are puzzle games, what it's essentially doing is it's giving you a problem to solve. And in order to solve that problem, you need to do something. And when you do something, that means you learned how to do that thing. You learned that rule of the game. And then it's going to give you another puzzle, and that's going to show you another rule. But then it might give you a puzzle that connects those two rules. You need to use both of those two rules that you learned in order to do it. So let's say that I want to see how perceptual control theory relates to reward prediction error. Reward prediction error, that's a theory in neuroscience. Perceptual control theory, that's a theory in the psychology of self-regulation. And when I'm saying perceptual control theory, so I want to see like both of those together. So like a simple way to do a query might be to say, and perceptual control theory, reward prediction error. But each of those terms has multiple ways that I can express it. Like reward prediction error, that's the same as RPE. And Wolfram Schultz, that's a professor that has written about it before. Perceptual control theory, that's the same as PCT. That's the same. And, if there's any notes that are tagged with Warren Mansell, that's also going to be relevant to that idea. So basically, I want to understand how these two concepts connect with each other. But there's multiple ways to express each of those concepts. Group A is everything reward prediction error. Group B is everything perceptual control theory. So now I'm going to do that in a query with the AND command and the OR command embedded within it. Or I have OR PCT perceptual control theory Warren Mansell all within these curly brackets. And that's saying these terms are all the same. If any of these show up, I care about it. And then I also have OR reward prediction error, RPE, and Wolfram Schultz. That's what I was showing you with aliases. All of these are relevant. And all of that is embedded within this AND command, right? So now that's saying anything that's in group A, if any of the terms that are in group A or any of the terms that if any of the terms that are in group A and any of the terms that are in group B are in a block of text in conjunction with each other, then that's valuable to me. That's what I'm essentially saying here. And now I have this beautiful query for this. So as you can probably start to see, queries are incredibly powerful. They let you start to see the connections between ideas. They let you gather all of the information that's relevant for something. They let you ask the question really effectively of what have I written that's relevant to this thing that I'm looking for, right? And once you start to gain this fluency with queries, then you can really unlock your own database. You can wrangle it. You can write as much as you want into it, and it doesn't matter where you put it. As long as you have some tags that are relevant to it, as long as you put these page names in it, then you're going to be able to find that note, and you're going to be able to have it resurface in the situations where you want it to resurface. So I really hope that this was all helpful. Please let me know. Give me some feedback. Leave comments. Like, subscribe. This all tells me what was good about this video and what was confusing about this video. And it also helps other people who need it to see it. So let me know if you want to see more videos like this. And I can really just start delving into what does Rome power usage look like.